Hello children, today we start the next topic, that is chemical changes and reactions. So we have already finished our chapter 1, which was language of chemistry. So once again I will like to tell you that kindly go through the symbols and the formulas very well. You should know all the symbols and formulas for chemical compounds. Okay, now once you know the chemical compounds, their formulas, this chapter is going to be very easy. So the second chapter, chemical changes and chemical reactions. So first thing, what is a chemical change? A chemical change is a permanent change in which the chemical composition of a substance is changed and one or more new substance with different chemical composition and different property is formed. Okay, so what is a chemical change? Chemical change is something that can be represented by a chemical equation. So when the change is permanent, it's called as a chemical change. We have seen all these various definitions till now. Okay, so what is it about chemical change that you are going to learn today? We are going to see the chemical change, chemical bond, and the factors or the conditions that are required for chemical change. Okay. So what is a chemical bond? Chemical bond is a force that holds the atoms of a molecules together. Okay. When we see that a new compound is formed or any compound is existing, how does a compound exist? Why do 2 or 3 elements or atoms of different elements attach together and be so stable? So there is some kind of a bond between them, some force that holds them together. This force is called as a chemical bond. A chemical bond is generally represented by a hyphen. This we are going to learn in the following chapters. Okay, now let us see what are the factors that are required for a chemical change to take place. Okay, or the conditions which are necessary for the chemical change to take place. First thing is mixing. A close contact is required if a chemical change has to take place. Generally, it requires the two substances to be mixed, maybe in their solid states. So now we are going to see different conditions in which a chemical reaction can take place. So first condition is mixing or close contact. So here we are seeing that if they are in solid states and they are brought in close contact, also chemical reaction can take place. Example, if iodine and phosphorus react, they react explosively when they are brought in close contact. You may also see examples given in the textbook. Okay, now let us see the next condition which is required. In some cases, the chemical reaction occurs when they are mixed either in their molten or in their aqueous state. So sometimes it is necessary for the participant reactants to be in molten or in liquid state, aqueous state, then only the reaction takes place. Here there is some example given. It's oxalic acid crystals and sodium carbonate react in water solution only. So only when they are in aqueous solution, in the solution of water. What is an aqueous solution? Where the solution contains some amount of water. So only in presence of water or in an aqueous solution they react, oxalic acid and sodium carbonate. Let's see the other condition. We have one more condition here, which is heat. Okay, so some chemical reactions occur only when heating is done. So you cannot have these reactions if heating is not done. Let's see the example, copper carbonate. We have many decomposition reactions we are going to study. We've seen them last year in 8th standard. We are going to see them further in the next chapters, in the upcoming chapters. So for decomposition, thermal decomposition, heat is necessary. Okay, so example, copper carbonate will decompose on heating into copper oxide and carbon dioxide. So heat is one of the necessary factor for a chemical reaction to take place. Similarly, you have examples of even lead nitrate. Lead nitrate can decompose, giving you 3 substances, that is lead oxide, nitric oxide and oxygen. The fourth condition necessary for chemical change is light. Some chemical reactions take place by the action of light. We have also seen which is a reaction that all of you know, that is photosynthesis. Photosynthesis mostly takes place in presence of light. Okay, so some chemical reactions take place by the action of light. These are called as photochemical reactions or photolysis. So in presence of light, some reactions take place. So the condition necessary here will be presence of light. So if there is no sunlight, if there is no light, if it is in a dark room, such reactions will not take place. Okay, now let us see the next condition necessary for a chemical change. One of the conditions, that is electricity. Okay, electricity. Certain chemical reactions like decomposition reactions of certain compounds occur only when electricity is passed through the substance. So we see that some compounds are there. They can undergo decomposition only when electricity is passed through them. How much you heat them, no matter how, at what temperatures you may heat them, they are not going to decompose. But they require electricity. So these are called as electrochemical reactions. Okay. So example is of water. If you want to separate water into hydrogen and oxygen, if you heat it above its boiling point, it is only going to vaporize. You cannot separate hydrogen and oxygen from that. But in case you pass electricity, okay, then we can separate it into hydrogen and oxygen. This is the same with sodium chloride also. Salt, common salt or sodium chloride on heating will not decompose, but it requires electricity to decompose. Okay, now let's see the next condition. And the next condition is pressure. Some chemical reactions take place only when the involved substances are subjected to high pressure. Now in this case, mostly if you see, there will be the reactions in which gases are taking part. If you see, the molecules of gases are far apart from each other. So naturally you need to bring the particles close to each other so that they collide with each other. So in this case, when we have gases reacting, we need to subject them to pressure, and mostly some high pressure. The most common example here, nitrogen plus hydrogen at about 200 atmosphere pressure gives you ammonia gas. So pressure is one of the conditions necessary sometimes for some of the reaction to take place. Now let's see the next condition, that is the catalyst. So what's a catalyst? We have seen catalyst right from our 6th, 7th and 8th standards. So catalyst is something that helps to speed up a reaction. That is what we know. So some chemical reactions need a catalyst to speed up, that is accelerate. Or even sometimes catalysts are used to decelerate the rate of reaction. Suppose a rate of reaction is happening at a very high speed and we do not want it at that speed. We want to control the rate of reaction. In that case also a catalyst is used. Now based on what parameter we are using the catalyst for, the catalyst which is used to speed up a reaction is called as a positive catalyst, and a catalyst which is used to reduce the rate of reaction or decelerate the rate of reaction is called as a negative catalyst.